Welcome to 4.5. This is U substitution, and this is about day 3 for us. And it is, you'll see a little twist on it. I've got it labeled another kind of substitution, and it is still U sub, but sometimes it doesn't always work out that we can replace everything initially off of our original U sub. So that's where we're headed today. And let's just follow through. We know we should choose this as U, so let's let U equal 2x minus 1 and see where that takes us. So du dx would equal 2, and we know we'll multiply up by dx, and that tells me that du equals dx. However, I know that I've got just a dx, and then I've got this x going on. So, I really just need x, so let's get rid of this 2 by multiplying by 1/2, and then we'll get that cancel to divide and make 1. So 1/2 du will be our dx. There's 1/2. Du makes the dx. This will be u to the 1/2. And here is a problem because this x did not fall away with this 1/2 du being equivalent to dx. So this is really where the issue comes in today. What do we do with this x? And there's a solution for it. Of course there is, right? What we can do is take and make this into an x. So I'm going to take and solve for x. So u equals 2x minus 1. Let's solve this for x. So let's add 1 to each side, of course, and that gives us u plus 1 equals 2x. Now let's divide both sides by 2, and that's going to give me an x and a 1/2 u plus 1. Believe it or not, we just figured out what x is. So for x over here, I am going to replace this x with 1/2 of u plus 1. And then I've got this u to the 1/2 and a 1/2 du. Let's bring our 1/2 out front from here. So we'll move that to the beginning. That other 1/2, we could do the same thing. So that's going to bring up a 1/4 integral. And then let's distribute. So we get u to the 3/2 plus u to the 1/2. Now there's a lot of algebra that we just did, but that's all that was just a lot of algebra to clean up our integral, to make it possible to do a nice u substitution here. So this is going to be 1/4 u to the 5/2 times the 2/5. I'm going to hold that 1/4 out front. All right, so continuing here, we'll take and do u to the 3/2, add a power, right? And then divide by that power, which is like multiplying by its reciprocal. Since this was an indefinite integral, we did not have any bounds, on our integral. That's an indefinite integral, so we get the plus c. And then all we need to do, let's clean this work up a little bit. I'm going to bring this over so I can utilize it. Let's distribute and clean up what we can. So we're going to get 2/20, the same thing as 1/10, u to the 5/2 plus 2/12, that would be a 1/6. 1/6 u to the, let's go u to the 3/2, and then we get plus c. And that'll give us a 1/10. Now let's substitute back for our u, and u was originally set up to be 2x minus 1 plus a 1/6, that's for the 5/2 power, 1/6 2x minus 1 to the 3/2 power plus c. And there, we're able to solve it. Next. Example here. What do you think you should let u equal? Well, typically you're going to try to spy the more complicated function the composite function, and I'm seeing it right there, I would have 4 minus x to the 1/2 power. So 4 minus x would be my inside function. Let's let u equal that. Therefore, du would be the derivative negative dx. Do I need negative dx? Well, I've got just a dx, and so let's make this multiply both sides by a negative, giving us negative du as a replacement for that dx. I've got this taken care of. That's simply our u. We know this is a negative du replacing dx. What I fail to have here is something that's going to replace the 2x plus 1. So we'll do our very best. In the meantime, maybe I'll just update what I have so far. It's kind of an intermediate work step for me, and I'm doing it mainly so I can kind of keep track myself of what I have yet to replace. What I need to replace, of course, is the 2x plus 1, because I want to write everything in terms of u. So we're going to take this first column and let's solve for x. And that's just simply algebra, isn't it, 4? So subtract 4, we get u minus 4 equals negative x. Multiply both sides by a negative, and that's going to give me negative u plus a 4. And I could say then that's 4 minus u, just ease of writing it. So back over to our work here. Whoops, don't want that color. Let's go with the purple here and replace what we can. Well, all I know about is x, correct? I know that x is equivalent to 4 minus u. So to replace x with 4 minus u, I still have a plus 1 on the outside there. And all of that is going to get multiplied by u to the 1/2. The negative, let's pop it outside, and then we get du. So you just got to be really careful about your work here. I think the next thing I would do is probably distribute and simplify what I can in my initial statement here of this integrand. So we're looking at 8 minus 2u plus a 1. All of that stuff is in parentheses. It will get multiplied by u to the 1/2. Now, a little bit of simplifying within that parenthesis will give us 9 minus 2u. And then I have a u to the 1/2 du. Yep, you're right. Let's distribute. Keep simplifying before we integrate. And that'll give us a 9u to the 1/2 minus 2u to the 3/2. Add those exponents. And that's a du out there. Kind of come over here and work. So I think I'm in the stage of actually integrating. So, but I can't forget I've got that negative out front. So integration is going to be 9u add a power that gets us up to a 3/2. Divide by 3/2. Of course, multiplying that by 2/3 is the same operation. 2 up a power, that's going to take me to 5/2. Dividing by 5/2 like multiplying by 2/5. And put that in parentheses because we knew we needed to distribute this negative, and then plus c since we're an indefinite. Distribute negative, that's going to give us, oh, we got a little fun going on here. Simplify that, so I'm going to have negative 6 u to the 3/2. Let's replace our u with a 4 minus x to the 3/2. I get 2 times 2 is 4, 4/5. Negative times negative is going to be, remember we took this, negative times negative is going to give us a positive here, 4/5, multiplied by 4 minus x is our replacement for u, that's to the 5/2 plus c. And there we go. So not that much harder, you guys. You just have to be careful. It's probably going to get more complicated. So just be careful with your algebra. Example, the third example, the thing that I first captured my eye when I saw this is we haven't had to do that style yet. We're going to be on a definite integral, so we want to make sure we work with those bounds. The next thing I look for is usually my u should come from probably the denominator. Um, and I see that composite function there, so that even solidifies it. I believe my choice of setting u equal to 2x minus 1 is probably a good move for my u substitution. Okay, so let's proceed through with this. Du then would be 2 dx, and we notice we have an x dx, but the best I'm going to be able to do is replace my dx probably right now. Let's go with dividing by 2 or multiplying by half so we got this replacement figured out. I've got this figured out, that's u. What I don't have figured out is my x. If you wanted to, you could track your progress. I'm sitting with, the square root of u and then a 1/2 du replacing that dx. And of course, we're talking about this x. So that's going to require a double substitution is kind of how I like to think of it. So another sub going on. Let's maybe pop this one in green. Whoops, let's throw this one in green. So this is going to be solved for x. So we can double sub. So from there, I'm going to take the u equals 2x minus 1, modify it a bit, add 1 to both sides. That gives me a u plus 1 equals 2x, and that'll make x equal to 1/2 of u plus 1. There's my replacement for x. So we're going to replace x with that, and that should help the progress here. All right, so x becomes 1/2. I could throw out front. X was u plus 1. This u that's from the bottom, let's call that u to the negative 1/2. I have this 1/2 here. Let's throw it outside. And then that give me just du. So a lot of sorting going on there, right? We will do some distributing of that u so we can simplify our integrand, and I can see out front I have a 1/4. So I have 1/4 integrand of u to the 3/2 plus u to the negative. Oh, that's not correct, is it? I just caught there was a negative there. Negative 1/2 plus a positive 1 would give us a positive 1/2. And that'll be a du times all of that stuff. The 1/4 out front. Oh, the thing you're probably wondering is like, oh, is she going to remember that we were a bounded integral? We were definite integral. I just thought of that too. So let's deal with that. At least we've got, this part figured out. So that's helpful. On to figuring out what our bounds should be. So let's create these bounds. Change the bounds. So I knew that x was equal to 1, which would imply that u would be equal to, well, I have this relationship up here between u and x, so let's utilize it. That'll be a 2 times a 1 minus a 1. 2 minus 1 is 1. No change, it appears, but this is a u, whoops, we don't want that. This is a u equals 1 now. When x is the top was 5, when x is 5, that will imply that u is 2 times 5 minus a 1, giving us 9. Our upper bound is shifting to 9 now. Throw these little icons over. Yeah, so we got u. I think it's all ready to be processed here. So the 1/4 out front, not a problem. Let's integrate u to the 3/2 makes it a multiple of 2/3, multiplying it. And then add a power, we're a u to the positive 1/2, dividing by 1/2, that's like multiplying by 2 over 1. And this is ranging from 1 up to 9 for our integral values. Let me get some extension here so we can proceed with our integration. Now that everything is in terms of u, there's no turning back, right? Well, I don't want to turn back. Maybe you do. I'm going to work in U's. So 9 goes in. I'm going to have 2/3 of 9 raised to the 3 halves plus 2 times 9 to the 1/2 power. That is my f of 9. Now let's go with the f of 1, where I'm just kind of laying out your fundamental theorem of calculus here. So minus 1 goes in. 1 is such a lovely number. So that's going to give me 2/3 times 1 plus 2 times the 1, so just 2. Big brackets to close this off, because remember our fundamental theorem, really, I have 1/4 going on, don't I? So there's the premise that we're working off of. 1/4, I'm going to hold on to that because I've got a lot of work to process inside of here. So let's work forward on that. 9 to the 3 halves power, that is a square root of 9, then cubed, times the 2/5 plus 2 times the square root of 9. Boom. Minus, I'm working on, right now I guess I'm working on this. So that's like 6/3, so I'm getting an 8/3. Yeah, minus 8/3. Close off that big bracket. And more basic arithmetic here. Square root of 9 is a 2. 2 times 3 is 16, I believe. Okay, I paused the thing because I thought I had some errors because I didn't remember the number 16 coming through. And obviously, square root of 9 is not a 2. That would be a 3 there. And this was just a 2/3. I'm not sure where I meant to 2/5. So this should be 2/3. So update your numbers. Now we've got 3 raised to the 3rd here. 3 raised to the 3rd is 27. And then I've got 3 going into 27 9 times. So that looks like it should produce 18 for me. And then square root of 9 is a 3. 2 times 3 is going to be a plus 6. And then I have the 8/3, so minus 8/3 going on. Keep proceeding. We got 1/4. 24 minus 8/3. 24 would be 72/3 minus 8/3. We're almost there. I'm so excited. 64/3. But 4 goes into 64, I would suppose. That'll go in there 1 time. With the remainder of 2, 4 goes into 24 16 times. We're over 3. How about 16/3? I love it. Hey, double check though. What you can do, take your graphing calculator and throw it in there. See what you get for your numeric derivative. I think you're going to find it to be 16/3. All right, there's one more here of the definite integral style. I think I'll let you work through that. I will tell you what I ended up with once I got all my substitutions done, my u values. Came into that, I ended up with u to the 2/3 minus u to the negative 1/3 and du. So do all your substituting and see if you can get yourself to that point. My overall answer then came out to be 141/10, which we know, of course, is 14.1. So I'm going to let you do that just to save a little time. Example, a very common AP problem. I took this from a multiple choice one. Let g be a continuous function using the substitution u equals 2x minus 1. And you should be celebrating, right? They're telling you what to set up for your u substitution. You've got this integral that looks a little funky. We've got g of a function. But the function is u from what I can see, isn't it? Dx is equal to which of the following? So let's just go ahead and start this problem. Let's say, okay, we've got 2/3 g of 2x minus 1 dx. Yes, you should write out quite a bit of stuff when you're working multiple choice. So their suggestion or their instruction was to let u equal that. Well, we know, let's proceed through the du dx, but I'm going to multiply up by dx, bringing it to this side. That the derivative on the right is simply 2, and when I look at my problem, I don't need 2 dx's, I just need a single dx, so I have a 1/2 du equaling dx. So I'm going to come over here and update what I know. G of u, right, this is all u, dx is a 1/2 du. And the next thing I should do is update these bounds, because when I look at their answers, I'm seeing all this u stuff. Well, then these also need to be u. And so let's change our bounds. And that bound change, when x is 2, u would become, based on this rule, 2 times 2 minus 1. That's a 4 minus 1 gives me 3. My bounds on the bottom is a 3 when x is, what's the upper bound? Whoops, wrong place. Right there, a 3 when x is 3. U would be, back to this rule, 2 times our 3 minus our 1 would give me 6 minus 1 is a 5. Okay, that's a 5. So I'm looking for, whoops, grabbed all of it here. I'm looking for a multiple choice that matches. That means I could bring out this 1/2, couldn't it? 1/2 bounds 3 to 5 g of u du. I'm liking D. The last little bit is a little bit of a repeat. We've talked about even functions. Well, you should have talked about them in pre-calc quite often. Then this says, given a function that's even, then f has y-axis symmetry, because when I plug in negative x, I still get out the original f of x. That describes an even function. So, even function. Oh, you know what's a nice even function? An absolute value function when it's centered at 0. So that'd be y equals absolute value of x. I'm going to go with that one right now. So we could look at area under the curve, couldn't we? Let's say this is a and over here is negative a. So I'm looking for the region under the curve. That would be this area here and this area here. And I think I can proceed and answer questions. Oh, so basically, if I have area here of some amount, let's just say it's some k amount, then I also have a k amount over there. So this is given this problem. Let's just kind of think of, would it be wrong to think of the absolute value function? So I'm just going to create out to 5, and here's my 0. It told me this has an area of 3. The region under the curve there would be 3. Likewise, I could say from negative 5 over here, it would have an area of 3. So when it says, what's the area from negative 5 to positive 5? Well, they're talking all the area under the curve. I'm going to have a 3 plus 3 or 6. Nice, easy problem. What about from negative 5 to 0? Oh, that matches from the same right side when I went 0 to 5. What about negative 5 to 5 of 4 times f of x? Well, multipliers can be brought out front. If I'm multiplying the entire function times 4, bring it out front. Now I know I've got 4, and this integral evaluates to 6. We did that already. So I'm going to get 24. Well, if we study even, we better give odd its fair shake. So let's create an odd function. I'm thinking like maybe y equals x cubed. How about that? And then it's saying from a to negative a, they're giving us 5. So let's just pretend this is our problem. From 0 to 5, the area under the curve would be this space here, and it has a value of 3. So I've got a value of 3 going on here. So the first question, of course, is going to ask from negative 5 to 5. Negative 5 would be positioned over here, and My region under the curve would be this region, wouldn't it? And that region would have a -3 area since it's under the x-axis. So I can tell from -3 to +3, they zero out. I'd have -3 plus 3 gives me 0. -5 to 0, then we're talking this region. That's a -3. And there's one more question. I think it's a 4 multiplier, which we talked about last time. Let's bring our 4 out front. -5 to 5, we've already calculated out as 0. So 4 times the 0 equals 0. Okay, that is the lesson that we will be working on for the third day. This is an excellent worksheet here. It gives you lots of good practice, plus just a little bit of review. Borrowed from another instructor named Nancy Stephenson. So let's do Nancy's worksheet for a little bit of practice and have fun with that. Hopefully you capture this substitution of another kind. Thanks, guys.